Okay, we're going to carry on with the penultimate session on the application stage today. Dr. Leonhard Klein from Siemens Mobility is going to be talking about how additive manufacturing addresses challenges in the rail industry to try and achieve 100% system availability. He'll explore on-demand parts that we've heard about today, some fleet modernization, sustainable maintenance, and highlighting a flame-retardant SLS powder as well, which can help to meet stringent rail safety regulations. So, Dr. Klein, over to you. Thank you.
So yeah, thanks very much for the nice intro and for giving me the opportunity to speak today on the application stage. So my name is Leo Klein. I'm the Business Development Manager for Additive Manufacturing at Siemens Mobility. And yeah, in the course of the next 20 minutes, I will give you an overview of 3D printing within the rail sector. So first of all, what are the challenges within rail in general? What is Siemens Mobility doing actually in terms of additive? And yeah, what are the typical application areas for 3D printing within rail? And I will also give you yeah, some insights into one of our recent innovations on yeah, a new material for rail. All right, current challenges. So we at Siemens Mobility, we are producing rail systems, which means vehicles, rail infrastructure, services, project management, but especially spare part services. And those systems are quite expensive and yeah, long-term investments, so they have to work reliably. That's very important. And our goal is to assure 100% system availability. And yeah, if you're working within Siemens for customer services, you have to find answers for specific challenges. So the first one, it's a very long lifetime. So usually for the vehicles, the lifetimes are about 30 to 50 years. And for the rail infrastructure, it's about double that time. So you have to supply everything with spare parts all the time. And yeah, imagine you have to operate fleets worldwide, quite often customer specific. So you have small part quantities, you have a high variety of parts, and a lot of suppliers, which means this is quite challenging. In addition, Siemens also has quite high sustainability, let's say, targets, which is quite challenging because you always have a high cost pressure in railways as well. So it seems that additive is, yeah, quite a perfect match in order to tackle those challenges, in order to solve non-availabilities, which we call obsolescence cases. But still, you have here quite high sophisticated standards. So the whole world of standards, regional regulations, which makes it in the end very challenging in order to implement additive or to change like conventional solutions to additive ones, especially within vehicles that are already like on the market, that are already approved, especially if those are safety critical ones. So what is Siemens Mobility doing in terms of additive? So we started about 10 years ago, so around about 2014. So I'd just like to give you a short overview of our activities. So R&D, that's an important element of our activities. So it is still very challenging to get 3D printed parts, as I said, into safety critical areas. So we already did that. We were successful. So this is a quite nice application here, the suspension lock for the Hamburger Hochbahn. This was a project carried out a few years ago, but still it was very, let's say, time consuming. It was very challenging, very expensive. So it is still one of the ongoing R&D projects to try to get this approval process shorter and much cheaper. And we're working here closely with our external partners and customers. And also very important, a functioning and working quality assurance process, especially if you are focusing on AM serial production, as we are doing, and especially if you are working in a global printer network. but we have that in place. So we get recertified every year by TÜV Nord according to ISO ASTM 52920. And also an important thing is AM redesign. So we are not just trying to print a part one-to-one compared to the conventional one. We are always trying to implement additional added values to the part, to the customer, and to make those parts better, which we call easy spareivation part. And also important for us is to combine our additive know-how with the train engineering know-how, plus existing Siemens Mobility digital solutions. So one of those solutions, as you can see here, it's called Mobase. So it's a digital platform comparable to Amazon, just for rail products. So you can order here conventional, but also additive parts quite easily. And also quite nice is the Easy Spares Idea app. So if you walk through a train, if you want to order a specific spare part, you just take a picture with your mobile phone with the app on it. The app identifies, okay, it's spare part XYZ. Then you place the spare part into your Mobase shopping cart, so to speak, and just order it with a few clicks. So just a few more numbers, facts, what we did in the 10 years. So within Siemens Mobility, we have a network of more than 18 locations globally that are dealing with 3D printing. So the focus, as you can see, is still Europe. So within Germany, we have a lot of important sites. I will give you some more details on that just in 1 minute. And globally, we have more than 65 printers, but also sites with specific additive manufacturing know-how. And so far, we served more than 110 customers with 3D printed solutions. And we have more than 2,000 parts on stock, so in virtual stock, so 3D data sets. And in total, more than 30,000 parts printed and sold to the customer. And also quite nice in the middle, as you can see, we got rewarded or awarded by one of our major customers, Deutsche Bahn, as best AM supplier in railways. So just a few facts, a few numbers on the global network. So quite Europe-centric, so to speak. So in Erlangen, in Germany, we have our center of competence. But we also have several other sites in Germany with industrial 3D printers, which is, for example, Wegberg in Western Germany, our test and validation center, Dortmund, Brunswick in Austria. We have an important site also with industrial 3D printers, large-scale ones, but also globally, as you can see, North America, Sacramento, or Asia, Bangkok. We also have sites with printers. So printers means the small ones, desktop printers, semi-professional, but also the really large-scale ones, for example, the F900 from Stratasys. So what are we doing actually, or what is, let's say, what are the typical application areas? So this is quite important of additive in the railway sector. Actually, we can, let's say, cluster it into 4 areas. So we have spare parts on demand. So this is a nice example of one of our major customers, BSAG, so Bremer Straßenbahn AG. During COVID, they had problems with specific side skirts. So they were not available during that COVID time for several months. And they called us. Basically, what we did is we redesigned those parts, we reinforced them, we segmented them, and implemented them to the vehicle just within 5 weeks. So from the first call to get them on the vehicle. And in the following, we also redesigned the complete front of the vehicles. So the good thing is, if you have a subsequent accident a few months after, you just have to replace the damaged parts, and you can leave the other ones on the vehicle. So you save lots of material. It's much more sustainable and very important. So the customer doesn't have to pay any penalties, or he doesn't have any longer vehicle downtimes. And also an important application area, that's the co-creation for modernization. So with our customer Stadtwerke Ulm, so at first glance you would say, okay, those are two completely different trams, but actually those two trams are the same. We just modernized the front, so the headlights, and those outer skirts here. And we did that in close collaboration with our customer. And the important thing is that the customer just has to keep just one type of headlights on stock, and in general, he just orders the parts from us, so he has much less stock on his side. Sustainable maintenance, also very important on our sites, in our depots. So this is quite a nice example on the bottom left side. So you had here an, let's say, overhead compartment, and just a tiny area was damaged. So this area here. And usually you had to replace the complete aluminum carrier, which was a waste of material. Actually, we didn't have this carrier on stock in Dortmund. And it would have been a waste of material and money. So what we did is we redesigned this, let's say, tiny area of the carrier. We identified it as the new smallest exchangeable unit, and in the end repaired this carrier with the additive solution. So it saved more than 90% of material. It was very sustainable. CO2 equivalents of more than 10% were saved, so it was quite a nice use case. And also very important, serial production on the top left side. So this is an air conveyance ejector, as it is called. Basically, it's a water ejection nozzle, and it's used in order to evacuate freshwater tanks in winter. Actually, all the time, but especially in winter, it's important because here you have to get rid of all the water in the tanks. Otherwise, the pipes freeze, get damaged, and the important thing is here we improve the performance of the ejector. So by redesigning it, by improving the design, implementing internal flow channels, it was possible to improve the flow rate by a factor of 5 and to reduce the weight by 75%. So it is much better actually, and now it's implemented into all the Mireo and the Zero regional trains all over the world. So what I also want to present today, as I said, is one of our recent innovations from Team Siemens. So this is the first applicable SLS material for railways, which fulfills EN 45, 545 flame retardancy demands. And I would like to give you some more details on that. So how did this development roadmap look like? So we started here in 2016. And the basic questions were, okay, which AM material is actually suitable for railways? Because we have some key requirements. For example, as I said, so the flame retardancy, it has to be fulfilled. It has to be a sustainable material. It has to be relatively cheap because of the, let's say, price restrictions. And basically, there were just two technologies which were suitable. So FDM on the one hand side, and SLS on the other hand side. And SLS was the most promising one. But we actually only had a few materials that were relevant. So for FDM, there was, or still is, PEI. So it is much cheaper than PEEK, but still pretty expensive. It shows quite good mechanical properties, and it is suitable for FDM, but actually we favored SLS. And for SLS, there was only PEEK, which is super expensive. You had aging effects, The powder was not really sustainable and reusable. So basically for SCS, there was no suitable material for railways. So this was the starting point. So we said, okay, we want to develop an SLS material for railways. We did extensive material testing. We actually identified a material in 2019. Then we did a development agreement with the company LehVoss a few years ago, additional process and material optimizations. And actually this year, we released the material on the AM forum, but still there are a few more things to do, like material and machine qualification, in order to release it for production. And so what's the material now? So it's a patented innovation from Siemens, as I said. So it's the first flame retardant and sustainable SLS material for railways. It's called LehVoss PPS 9268BK. So it's a PPS-based material. So with all the, let's say, key properties of a PPS. And so the key benefits you can see here. So it fulfills really the highest fire protection standards according to EN 45, 545. It is 100% reusable. It has very good dielectric strength and chemical resistance properties. Very important, the material price, it's quite comparable to PA12, and it's printable with CO2 and fiber lasers. But still, so in order to print the material, you need a printer with high temperature processing. So you need temperatures of about 250 degrees C. For us, for the rail industry, you need quite large build spaces. That's an additional requirement. And the machine needs to be, let's say, relatively cheap, not too expensive, as I said, because of the high cost pressure. So that's still something that's ongoing in order to find a proper machine and to process this material really suitable for railways. Something else that I wanted to present to you is, okay, what do we do in addition to that? So just two examples for ongoing research projects. So for example, the 3D fiber train project, quite interesting. So we are here, let's say, just an associated partner. But it's pretty cool because it's about identifying a new 3D printing process in order to manufacture 3D printed parts, fiber reinforced, large scale, large format parts for heavy duty exterior applications in railways. But actually the most important project for us, that's the Digizug 3D. So it's a project with lots of partners. You can see them here. It's the main goals, I would say, are to get something, to get a digital approval of such rail parts, so faster and cheaper approval, to get a digital mapping of this approval process, and to not have all this testing that takes a lot of time, but just to have it calculation based. And in addition to that, we also want to identify additional digital methods like process monitoring systems and automated data processing in order to get this whole approval process faster and cheaper. Okay, and basically I'm almost at the end of my presentation, so thanks a lot for giving me this opportunity. Here you can see our contact details. I'm also willing to share those slides afterwards, so you can get in contact with us. Email address, homepage, our Mobase page in order to order rail parts. So feel free to ask questions now, also to get in touch with me afterwards. And if you have some time now after the talk, also feel free to get to our Siemens booth, because we also have here a couple of SLS parts that are printed out of this new material. And we can also have a discussion on that afterwards. So thanks a lot. And feel free to ask some questions if there are any.
Thank you, Leo. What was the key deciding factor between FDM and SLS that pushed you towards SLS rather than FDM?
Yes, as I said, so SLS was our desired technology, but there was no material for it. Actually, SLS was the technology for us in favor because we said, okay, we have better surface properties, for example. We have a process that is actually cheaper than the FDM ones. So we are currently printing with FDM, but we are always struggling with quite expensive parts. And we said, okay, SLS would be great, also much faster, but yeah, there was no suitable material so far, and that was our motivation in order to get this developed. So it took quite long, I think like 8 years, but yeah, it was worth it.
I think that's not too bad in terms of a material development process. 8 years is pretty good, right?
Yeah.
Okay, thank you very much. And yes, I think Hall 12, the Siemens booth, you can go down there and take a look and speak to the people there about the material and the rest of the AM applications that Siemens are showing this week. So, yeah, thank you.
All right, thank you very much.